simultaneous equation here, and if I try adding the lines, I won't get rid of the x's or the y's. If I tried subtracting the lines, no, I won't get rid of the x's or the y's. So what I'm going to do is I'm going to multiply that top line by 3. And then I should be able to get rid of the y's, because I'd have a minus 9y and a plus 9y there. So that gives me 6x minus 9y is equal to 54. 5x plus 9y is equal to minus 10. 11x is equal to 44, which means x is 4. If x is 4, throw it back in. So that's 2 times x minus 3y is equal to 18. That's 2 times 4 minus 3y is equal to 18. 8 minus 3y is equal to 18. Subtract 8 from both sides. Sorry, I'm ahead of myself. Minus 3y is equal to 10, and divide by minus 3, or if you want to, you can change your signs now, multiply by minus 1, and then divide by 3. So y is equal to minus 10 over 3, or minus 3 1/3, or minus 3.333, or minus 3.3 with a dot on it. Make sure you don't write down minus 3.3. It'll be minus 3.3 with that dot on it. But they didn't ask for it in any manner, so I'm going to leave it like that. Verify your answer to part 1 above. Verify just means prove it, like show that what you got was correct. So I'm going to verify it by throwing it back into both the lines. So 2x minus 3 times y should be equal to 18. So is that equal to 18? That's 8 plus 2. Yep, true. And then I'm going to verify for the other line. 5 times x plus 9 times minus 10 over 3. That should be equal to minus 10. Is it? Well, that's 20. Plus a minus, yeah, so plus and a minus is a minus. 90 over 3 is 30. Yeah, so that's 20 minus 30. That's definitely true as well. So I now have verified that my answers are right for both equations. Orla was asked to write down a quadratic sequence. She writes down the following. So we have 5, 6, 9, 14, 22, 30 and 41. Exactly one of these terms is incorrect. So quadratic is when we have the second difference is the same. So I'm going to start looking at the differences. So 5, 6, 9, 14, 22, 30, 41. Okay, so the difference there is a 1. And 3, 5. So, okay, this looks pretty good. 1, 3, 5 with a difference of 2. 2, yeah, okay, it all looks good. So this would be, oh no, it's an 8. Okay, so that's the issue. It should be 7, so that should be 21. If that was 21, let's just check it. If that was 21, then we'd have 9, 11. Yeah, that's her mistake there. That's a 21, not a 22. So correct sequence by only changing one of Orla's terms. 5, 6, 9, 14, 21, 30, 41. Kieran ran the 5-kilometre race. He drew the graph below to show the time that it took him to run a certain amount of kilometres during the race. And the part of Kieran's graph marked C is a vertical line. What does part C tell us about Kieran's running at this stage of the race? Give as much detail as possible. Well, this is his distance. So 0 to 1. So in the first kilometre, his time seemed to be pretty constantly going up. So the distance, yeah, his distance was, he was covering a distance of about 1 kilometre in approximately 5 minutes. If we go on to the second one, kind of looks similar. Another kilometre in, I'd say, just under 5 minutes. If we go to the next bit, oh, he's not moving. Because for this amount of time here, from about 10 until 15, it looks like he hasn't moved any kilometre at all. He's not, yeah, he stopped. So what do I want to say about his running stage of the race? He is covering 0 kilometres at that stage. He stays at 2 kilometres, if that's how you'd like to put it, for approximately 5 minutes, maybe 6 minutes. So he's taking a break in the race, or he's standing still, or he's not moving forwards or backwards. Whatever way you want to say that, as clearly as possible, he is taking a break for those few minutes. In the diagram below, the length of the sides is given in terms of x. X is a natural number. I'm going to highlight that for myself. And show that there's only one value for x for which this triangle is right angled. Well, a right angled triangle makes me think trigonometry. And trigonometry, where they mention all the sides, makes me think of Pythagoras' theorem. So that's the way Pythagoras' theorem is written in the log tables. Maybe you write it as hypotenuse squared is equal to opposite squared plus adjacent squared. I'm thinking of using this first because, as I said, they've mentioned it's a right angle triangle and they've mentioned all the sides. So hypotenuse, let's just try and fill this in, squared is equal to opposite squared, doesn't matter which way I write this, we don't know what the opposite and the adjacent are, plus adjacent squared. So my algebra better be pretty good here. To square something means to multiply it by itself. So if you want to, you could go over here to the side and just x plus 4 by x plus 4 gives me x squared plus 4x plus 4x plus 16, which is x squared plus 8x plus 16. Again, do that with this. Take it to the side, work it out. Gives me x squared minus 10x plus 25 plus, take that to the side, work it out. You'd end up with x squared minus 8x plus 16. Okay, looks pretty long, but I bet I can clean this up a little bit. We have an x squared and an x squared here, gives me a 2x squared. A minus 10x and a minus 8x gives me minus 18x. 25 and 16 gives me 41. And my left hand side looks like this. Now, I think I'm going to bring everything to one side and try and use maybe the minus b formula, or I think my camera keeps shaking a little bit. Just must be the table I have it on. Sorry. So what am I doing here? I'm going to take everything to one side. So I'm going to subtract x squared from both sides because I think I'm going to use my minus b formula. Very common way to finish a question at junior cert, and it's probably the most common way to finish a question at leaving cert. So I'm subtracting x squared from both sides, which leaves me with that. I'm going to subtract 8x from both sides, which leaves me with, you know, nothing here. The 8x is gone, and 8x from that is 26x. And I'm going to subtract 16 from both sides. Oh, actually, if I look at that earlier on there, I'll just be back to the 25. Off you go. Whether it's using the minus b formula, whatever way you want to solve that, I'm going to do it by the box method. So that's x squared, and that's a 25. I'm going to split this out, factor the 25, that add to give me 26, or 25x and 1x, and it has to be a minus 26. So I'm throwing in my signs there. X minus, because I use that sign, 25, and minus 1. So my two factors are x minus 1 and x plus 25. Sorry, apologies, x minus 25. Let each factor equal to 0. And x is equal to 1, x is equal to 25. Okay. So if I'm not paying attention to what they asked me at the start, I might give both those answers, but if I go back and just check it out, this is let's say a real life question where the length of a side is some number minus 4. So if it was 25 minus 4, that'd be 21, grand. But if it was 1 minus 4, that would be minus 3. And the length of a side cannot be a minus number. So I have to cross off that solution. And this is why I've now shown that there is only one value for x for which the triangle is right angled. I hope all that makes sense.